Hi everyone and welcome back to the multiverse of 100 plus data science project series. In this video, you will learn how to creating a predictive system for medical insurance charges using machine learning. So without wasting any time, let us start our tutorial right now. In order to creating here the predictive system for the medical insurance charges, we're going to using the dataset from the Kaggle that's called medical cost personal dataset. This is the dataset. You can simply going to click on here for download that. Let's make your hand dirty by importing here the NumPy, Pandas, and Matplotlib. Let's import here the NumPy as NP, import here Pandas as PD, import Matplotlib dot pyplot as PLT. Using NumPy, you can do the matrix multiplications. Using Pandas, you can load a dataset from your directory, as well as you can do the data visualizations as well as the manipulations. Using Matplotlib, you can basically do the data visualizations. And also you can importing here the Cborn as SNS. That's a Cborn as SNS. And after that, you're going to using here a style in terms of Matplotlib so that our data visualization graph look like cool. So you can use it here. Let's say using here the ggplot. Let's say ggplot. Otherwise, using the style, it look like the oldest one. Okay, the oldest version of Matplotlib. So in this case, I'm going to using here Python 3.8.5. You can using latest version of Pythons. So you can see it just give me some kind of warning loaded more than one DL from libs. You can also remove this by importing here the warning, or you can filter this out. Otherwise, you can running for the second time, it will automatically gone. Now we're going to load in the data set from our directory. So let's say pd.read underscore csv. So why CSV? Because our file that we here in our directory is nothing but one CSV file. So let's go on here. So you can see insurance.csv. CSV is nothing but called the comma separated value. That's why it's called the CSV. So you can give it the path. So let's say insurance. Let's in it should be insurance.csv like that. And now let us store it inside an variable. Let's say df. So let's say df is equal to this one. Let's say df dot head, and then you can see our data. So in our data set, we have in the seventh features column: age, sex, BMI, body mass index, children, smoker, regions, and the charges. So you can see charges is nothing but one continuous value. That's when the problem is based on regression problem, or you can say the supervised learning problem. So we actually identify the problem statement correctly. Now what I can do, we can see the information regarding the data set. So you can using here df.info. So here you can getting here the all of the column name, and it having not NaN value or not, as well as we can get in the data type from here. So you can see that in the each column it having the 1338 and no null, and data type is nothing but in 64, and in the sixth column is nothing but one object is nothing but an string columns. Same thing for a smoker regions, it's nothing but one string column, or you can say the categorical column. And we having the float 64 is nothing but 2, and int 64 is 2, and object is nothing but 3. That's when we have to handle in the categorical value on here in the case of data science. So we can also analyze the data more. We can do the data.describe to see the descriptive analysis of the data set. So in here we can get in here, okay, data not, it should be the df, sorry. So you can get in here the count, I mean how many count it have, the means, standard deviations, minimum, 25% percentile, 50% percentile, 75% percentile, as well as the maximum value. This is nothing but look like one bell curve, and in the bell curve middle it is called the 50%, and this portion is called the 25%, and this portion is called the 75%. So I don't have any pad, otherwise I will draw it out and try to make you understand, but just make it like that. You can search on Google that what is actually the percentile. Okay, so now let's checking here, is there a null value or not. Let's say df dot is null. So let's say is null or dot sum. So you can say that we don't have any NaN value, or you can say we don't have any missing value. So if you have any missing value, you need to also handling this out. You can drop the columns, otherwise you can replace them with the mean or median value. Otherwise you can replace them with the mode value as well. This is called the feature engineering, or you can say the missing value handling in the data. Sorry, not feature engineering. Actually, it's called the data preprocessing part. In the feature engineering, you're actually selecting here the best features. Now we're simply going to try to plotting some of the features from here. So you see that we having three categorical value, I mean sex, the smoker, and the region. So you can simply going to plotting this out using a pie chart so that you can see that how our data actually look like on here. So we can simply going to using here this matplotlib. So we have the features. So how can I get the features? You can using here df.columns, and you can getting here all of the features. So we can simply gonna store our categorical features inside a variable. That's a features, and inside this feature, I'm going to taking here the sex, and then I'm going to taking here this smoker and the region, because both of them are the categorical columns, right? So we can simply going to creating here one subplot, because we're going to plotting this out in a single plot with the three columns. So we can give it here one fixed size, and you can give it here, let's say 20 comma 10. It's hit and trial, you can change on here, it's based on you. And then I'm going to creating here a for loop. So we're going to creating here one enumerations of the features, because this is nothing but one data set column. So we can enumerate with the row and the column number. I is nothing but the row, you can make it as a row, but I just assume it as I. So let's enumerate, and then you're simply going to give it here the features that you selected on here. And then you can simply going to add the subplot. So let's subplot, and you can give it here 1 comma 3, so that you can plotting here 1 is to 3, I mean 1, it having the 3 column and the 1 row, and you can pass it here I plus 1. I plus 1 is nothing but the row, I mean each row it have just one row and 3 columns like that. So we can simply go to taking inside the x, so that's a df of column, I mean taking the all of the features column from here. So first it will draw here for the text, and second it will draw for the smoker, and third it will draw for the regions. And then you're going to do here the value counts. So let's say value counts, okay, sorry, value underscore counts, because you're going to creating here one pie plot. So let's say plt.py, and inside this pie plot I'm going to give it here x dot value, and then in the labels I'm going to give it here x dot index number, or you can also passing here the I as well. But labels is nothing but not like that. Labels is the value, how many value it have, I mean the unique value on here. And the auto cpt you can give it here. So let's say auto cpt, we can give it here, let's say 1.1 like that, okay. So let's say 1.1, and let's say this, you can just go on the Google and search for that what is O2CPT in the pipe, okay. So let's say plt.show. So why plt.show? So that you can show the graph in our Jupyter notebook, okay. Any errors? So pi got an expected keyword called auto-cpt, okay, should be the auto-pct, sorry, that's my bad. So just go on the Google, search for what is the auto-cpt or pct, sorry. So again error. So unsupported format character, this hash, okay, I hope so. I need to using here 1.1. So I need to using the floating point number, so that's why these problems it maybe happens. So in the case of our data, you can see that we having the 50.5% of the male and 49.5% of the female. But in the case of smoker, 80% are non-smoker and 20% are the smokers, one thing. And in the case of the region, it's nothing but the 1 by 4 like that. So you can see 24.3, 24.2 are mostly similar in the case of regions. We can see inside that. So now what I can do is simply going to see, uh, we can see that in terms of bird plot as well, so that you can see that how many labels we have, okay. So if I see the data set, you can see for the children it having 0 1 3 like that, I mean how many value it have, and if the data is actually the balance or not, so that you can checking on here. So for that, you can simply go into taking here another uh, uh, list. So inside that, you can give it here sex and the smoker, a smoker, and then we also have the children, because in the children we also having the uh, data. And BMI is nothing but a continuous value. So it's not needed to plotting this out. You can checking for this one. It's just having some unique value. So you can take it for the children. So let's say children as well. So let's say children, and then you can simply going to see here in terms of region, because we're getting here the unique value on here. And then you can simply go into do the group by based on the charges. I mean, based on the charges, how the value is actually affected. So we can check on here. So let's say plt.subplots, because those are the features having just 2 or 4 values. So we can simply go into uh, uh, compare with our target column, so that you can see that if the age is increases, charges is increases or not. Okay, just for ensure that is there any pattern or not. So let's say give it here the fixed size. So you can actually add this kind of thing in your thesis or papers or the PowerPoint presentations, so that you can notify, or you can actually make you understandable your teacher that yes sir, that's the data set I actually use it here. This kind of person are male, this kind of person are the female actually in our data sets. And you can also show here that this is nothing but my target columns, the charges, and based on that this bill is increases and this bill is not, like that. So we can simply go into creating here same thing. Let's say for I in column in enumerate, and then you can add it here the features. Let's say features, and then after that you're going to add it here the subplots. So let's say subplots. Let's say 2 2, and then I'm going to use here one I plus 1, and after that I'm going to group by. So let's say group by with the columns, and inside that you're going to pass it here the charges. So let's say charges, based on the charges how the value is changes. So let's say mean, and then I'm going to taking here as type. Let's say as type, and inside that I'm going to give it the floating point number, and let's say float dot bar. I mean, I'm going to see here the bar float, and then I'm going to see that plt dot show. So any errors? So axis got an unexpected keyword called fixed size. Okay, fixed size is equal to, okay, it should be subplots. It should be PL subplots is the fixed size of these ones. And see now. So you can see here. So based on the charges, most of them person are the female, sorry, male, and in the base of the charges, no are less compared to that in the charges. And in the children, the southeast part of the regions, it having the high charges. And if the person have the 3 children, it will maybe getting here the more charges. Okay, that's mean you can see that if the person have the more children, so or more child, so he may getting here more charges. I mean, he may get some more medical insurance charges. And if he's a smoker, if he's a smoker, I mean a smoker person is taking so much charges in the data sets, in our data sets, like that. Okay, so that's our data set descriptions. I mean, how it will look like. So you can also see here one thing. You can also plotting here on a scatter plot of the age and the BMI, because if I see the age and the BMI, age is nothing but one numerical column itself. So we can also plotting here a scatter plot, so that you can see that if the age increases, or if the BMI is increases, if the charges is increases or not, like that. So we can checking here, because this is not one categorical types of value. You don't have any unique value like that. It's nothing but a continuous value. So you can simply go into uh, uh, compare these ones based on the charges. So we can simply go into take it, let's say features, and then I'm going to eat here, let's say age and the BMI. And then after that plt dot subplots, and you're going to give it the fixed size. So let's say 20 comma 10. And then I'm going to copy this out, same thing, but I need to do some changes on here. So subplot it should be 1 comma 2, because it just have the 2 features columns. And instead of the df.group by, you're going to using here sns.scatterplot. And inside that I'm going to give it here data is nothing but my df, and x is nothing but my column, and y is nothing but my charges. And based on the charges, how the data actually changes. And you can give it here, let's say smoker, because you see that if they if the person is more, I mean smoked, so he may getting here better chances on here. You can give it to the smoker. You can also give it here this ages as well, because you passing the age, so you can also pass this here the male or the female columns as well. So let's say to shift enter. And in the case of no smoker, you can see no smoker is less and yes smoker is very high. If the probability of the score a smoker is actually increases, you may getting here high medical insurance on here. And in the case of this one, I mean in the case of BMI, if the BMI if the BMI is also increases, if the increases, it also getting the high charges. That's when you can see one thing here. If the person is a smoker, he obviously getting here high medical insurance charges. And if they smoke, if the person have the high BMI as well as he's a smoker, he may getting here the high medical insurance charges in the same of ages as well. That's mean we can see some kind of correlations between the features column to our target column. We can see on here. So now what I can do is simply going to see here, is there any outlier or not in our features column? Because you know that in the real-time data, it having the so many outlier. So not also involving that, otherwise our machine learning model unable to predict it correctly. So now let's checking here each column first, but it's better you can first dropping here the duplicate value from here. So let's try to drop the duplicate, because you see that it may having the duplicate value in the case of ages or in the case of BMI or in the case of any other column. So you can drop the duplicate value from here. So let's say drop, and you can using here duplicate, let's say duplicates, and you can simply going to pass it here in place is equal to true, so that it not getting here another data frame. So let's say it should be true like that. So here you go, and then you're going to creating here one box plot. So using box plot, you can see there is there any outlier in our data set or not. So let's checking for the each column first and see that is there any outlier or not. So in the case of ages, we don't see any outlier in here. So let's checking for the another one. So let's say we can copy this out, we can copy this out, and then you can simply going to pass it here the BMI. So in the case of BMI, you can see it having some kind of outlier. You can see it's called outliers, okay, which one is not necessary in terms of creating here the machine learning model. And machine learning model is quite sensitive in the outlier, okay. So we can also checking this outlier. We can also check in the outlier for another of them. So if I see here, these two values only continuous. One is the age, another one is the BMI, and all of the columns is just nothing but the categorical column. So we need to take in the outlier from the age and the BMI. But in the case of age, we don't see any outlier. But in the case of BMI, we actually see the outlier. So we need to removing the outlier on head. Okay. Now, how can you remove the outlier? So you can removing the outlier using one formula called interquartile range. Now, what is this I keyword and what is the formula for that? Now let's go on the Google and search for the IQR. What is that? So I just searched on Google and found this image from the Wikipedia. So this is called the I keyword. So in the I keyword, it having the one Q1 and the Q3. Q1 is called the lower quantile, and Q3 is called the upper quantile. I mean Q1, sorry, Q1 is called the lower quantile and Q3 is called the upper quantile. So if you're calculating here the lower quantile, this is a formula Q1 minus 1.5 into I keyword. And if you're calculating here the upper quantile, it's called a formula called Q3 plus 1.5 into I keyword. And if you see the bell graph, you can see 50%, 25% percentile, and a 75% percentile. I mean, if you adding this per 25%, 50%, and the 75% like that. And if you adding this, you can get in 100% or 99% like that. So this is called the IQR, or you can also opening here another images. So let's opening these images. In the case of box plot, you can see lower quantile Q1, median Q2, and upper quantile called Q3, and whisker is called, and you can see here outlier. So our motive is to actually removing this outlier using this formula, the IQR formula. Now let's go on the code and try to implementing this code on here. So what I can do is simply going to first initialize here the Q1. So our Q1 is nothing but the lower quant, right? So let's say df of, so let's say df of BMI. So BMI, and then you're going to taking here the quantile. So let's say QU and tile quantile, and we're simply going to give it here, let's say 0.25, 25% of the quantile. If I see while actually analyze descriptive analysis of that, 25%, 50%, and the 75%. So we can simply going to pass it to here. So Q1 is called the lower quantile. It should be the 25%, and Q2 is nothing but our median. So it should be the capital one. So let's say df of BMI, and then you can using here this quantile, and then you're going to using here, let's say 0.50, I mean 0.5, nothing but the 50%. And then you have the Q3, it's called df of BMI, BMI dot quantile, let's say 0.75. Cool. Now let's calculate the IQR. So how can you calculate the IQR? The formula is Q3 minus Q1. That's the formula you can search on Google. And then we need to calculate here the lower quantile. So you can say that, let's say lower limit or lower limit like that. So you can using here Q1 minus 1.5 into IQR. Let's say IQR. It should be capital, I hope so. So you can using here IQR, and then you have the upper limit, or you can say the upper quantile. So let's say okay, it should be the Q1 should be capital. Sorry for my mistake. I don't know why capsule is not working in some cases. I don't know why. So let's say Q3, and then you can using a plus 1.5 into, then you're going to using IQR. That's it. So that's our upper limit and the lower limit. So you can simply kind of printing these out. Let's say print here the low. We can make it as a lower limit. So let's say lower limit. So we can printing this out. Let's say lower underscore limit, and then you can simply kind of printing here the upper limit. So our lower limit is 13.67 and upper limit is 47.31. And that's mean our lower value is nothing but 13.67 and upper value is 47.31. So except them, all of them are considered as the outlier. So in case of BMI, if I see in case of BMI, if all the value is greater than 47, I hope so 47, I mean 47 like that, and those values considering as outlier. Okay. So now what I can do is simply going to do the feature engineering on here so that you can removing here the outlier from our data sets. So that's why we're installing here a library called the feature engines. So I'll buy the adapter because some noise is happening outside that door. So I need to stop the recording right now, and I'll back again. So in order to removing the outlier, we're going to using here a library called feature engine, a user-friendly feature engineering alternative to scikit-learn. So using this one, we can removing the outlier from the data, as well as you can do some kind of tasks like missing data imputations. You can do that, encoding of category feature, blah 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 blah. Okay, and if I go down, you can see that how can you actually installing this using this pip command, and also having some code you can read about that. So I'm going to using here this one outlier capping or removal, and I'm going to using here this one caps the maximum and minimum values at the user defined value. Maximum minimum, why? Because we're going to using here the IQR interquartile array. So that's why we're going to using here this arbitrary outlier clapper. So first I'm going to import it. So let's say from feature, okay, so feature engine. So make sure you install this library. So let's say feature engine dot outliers. So let's say outliers. So it should be layers. I'm going to import here the arbitrary, let's say arbitrary outlier clapper, this one. Okay, and after that I'm going to creating here an instance of the arbitrary outlier clapper. That's arbitrary outlier clapper, and inside that I'm going to give it here the min number of clapping in the from of dictionary. So our mean clapping value is nothing but 13.67 and maximum clapping is 47.31 dot dot dot. Okay. So let's give it to here. So our first one is called BMI, and BMI, this is nothing but this 13.67. This one we can copy this full value from here. And the second one is called the maximum. The maximum clapping, the dictionary. So let's say should be the capping, let's say dictionary, let's say dict, and then we're simply going to give it here the BMI, and we can give it to here this 47.31. This one we can copy this out, and I'm going to paste it to here. And after that we're simply going to store it inside a variable. Let's call it arb, and after that we're simply going to transform our data. Okay, because using this one you can do the transformation of the data. So let's say df of BMI, let's say BMI, and you're going to using here this arb dot feed underscore transform. Then we're going to give it to here this df of BMI, let's say BMI, and then we're simply going to run it. And after that let's see the box plot. So let's say sns dot box plot, and you can simply going to pass it here the df of BMI. Now you can see here all of the outlier is removed. We can clapping it to the maximum of the minimum values. That you can see that you can learn about that. How can you clapping here any interquartile risk value, or how can you remove the outlier from the data. Now we're simply going to uh, uh, taking here the skew value of the BMI and the ages, and let's see how the value is actually skewed. And after that we're simply going to convert our categorical features to the numerical. So let's see our data first. Let's say df dot head, that you can see that's our data. So in the case of age, it having different kind of age, and in the case of smoker, it having yes and no. So you can just simply going to actually we can just simply going to actually convert them to the mapping value. But before that is better, we can making this BMI value in terms of skewed, so that our machine learning can also getting some patterns. So let's say dm of age dot skew. You can also skip this step, but it's better you can skew the two things, okay, two value. So now what I can do, or you can also check in here this one df dot head. So same thing. So this is the skew value of that, and now you can see that the value is quite low. And if I checking for the BMI, then you can also see this just 2.23. That's mean after removing the outlier from the data. Now you can simply going to converting the categorical features to the numericals. So first what I can do is simply mapping this out. So let's say df of sex is equal to df of dot map, and we can simply going to map it to the male, and we can give it to the 0, and we have the female of the 1. So then it's simply going to converting here the smoker as well. Smoker, let's say df of a smoker. So a smoker obviously having the two value map, so we can simply going to say that yes or no. Let's say yes means let's say 1, and let's say no means 0. So let's say no is nothing but the zeros. Now what about these region one? So you can check that let's say df of region, and you can using here this dot unique, let's say unique. So you can see that it have the 4 unique value for that. So you can simply going to say that let's say df of region, and you can using here df of region, and you can simply going to using here map, and inside that we can first copy this one southeast. You can make any of them southeast northeast, but it's better we can following here one thing, Let's first follow the northwest, then we're going to follow the southeast. Okay, because northeast coming before the southeast. So let's give it here to the 0, and this is nothing but for the 1, and then it's coming for the southwest and the southeast. Okay, so we can give it to here, it should be the 2, and after that it should be the 3. Okay, that's it. Now you can checking for the correlation matrix as well. So you can see this is the correlation matrix of that. You can also printing here the heat map using this sns.heatmap, and you can passing here this df.correlations. So you can see that the children and the BMI is also okay. The sex columns and the children is also having some negatively correlated. Okay, but in the case of BMI to the age, it's also positively correlated as well. Not so high, but correlated. And in the case of charges to the BMI, it's also correlated. And those below in the charges of these columns is negatively correlated. I cannot pronounce this word too much. And regions is also negatively correlated. You can see that this column is not necessary at all, but let's see what happened here. Okay, now we're simply going to divide the data set into the dependent and the independent features. So let's say x equal to df dot drop. So let's say drop, and you can simply go into taking here the charges and accept the charges. So you're taking all of the things inside the x, and then you're going to give it to the axis. So our axis obviously should be the columns, I mean 1, and y is nothing but our df of charges. So we can using here, that's a df of charges. That's it. Now we need to importing here all of the important and necessary library in order to building our machine learning model. So this is nothing but a regression problem, so that's why you need to actually using here the regression types of machine learning model. So let's say from the scikit-learn model, we're going to import here, let's import here the linear regressions. Let's say linear regressions, and then you're going to also importing here the lasso. If it is needed, then you're going to use it. So let's say from scikit-learn dot sbm, we're going to importing here the sbr, and then from scikit-learn dot ensemble, I'm going to import it here the random forest regressors, and then we need to installing, I mean we need to using here another library called ensemble called the gradient boosting regressor. You can also import it in here because ensemble technique is nothing but inside the random forest and the gradient boosting. So you can using gradient boosting regressor as well. And after that, I'm going to import it here. Let's say from scikit-learn dot model selections. I'm going to import it here the train, test, and split. So it should be the train, test, and split. Aja, aja, aja. You can press the tab key from your keyboard for the auto suggestions. So let's say scikit-learn dot model selections. We're going to import it here the cross validation score. So let's say cross validation score, and then I'm going to also import from uh, xgb boost, importing here the xgb regressor. Okay, let's say xgb regressors. That's it. So now what I can do is simply going to divide our data set into train, test, and split. So I mean training part of the testing part, you can passing here x and y, and then you're going to give it to the test size should be the 0.2, and the random state you're going to using here random started from 30 to 50. So we can simply going to creating here one for loop. Let's say for I in range, so let's say 40 to 50. You can give it here any kind of random states, and for this random states uh how the value actually changes, because you're going to using the linear equations, that's why. Okay, so I'm going to give it to the random state because you're going to using the random kind of value for each of iterations, so that you can see that how the values changes. Now let us store it inside the variable called xtrain. Then you have the x test, then y train and y test. Let's say y train and y test. And now you're simply going to creating here a model. Let's say LR model is equal to linear regressions. And then you're going to using here LR model dot fit, and inside that you can pass it here our x train data and the y train data. And after that, because we're having the tan values, because we're getting here tan values from here in the random state, as well as we're getting here tan score for the model output, I mean model accuracy. So we can store it. Let's say L1, let's say L1 is equal to empty list, and L2 is equal to empty list, L3 is all to empty list. Why, I will show you later on. Then another one is called CBS is equal to 0. CBS stand for the cross validations. This one cross validations. That's why taking here three empty list as well as one variable for the cross validation scores. So now what I can do, first you're going to appending here to the L1. So let's append. First you're going to appending here the LR model dot score of the X train and the Y train. And second one we're going to append it, second one LR model dot score for the testing data. Let's say S test and the Y test. And then we're going to calculating here the cross validations. Let's say cross validations. So you're going to using here this cross validation score, and inside that you're going to give it here the LR model and the X, the Y, and I'm going to give it here the cross validation as a 5-fold, and taking the mean of that. And then I'm going to append it to the L3. By default value is 0. We just pass it here so that we don't get any negative value on here or any problems in the case of the variables. That's why. Okay, let's say CVS, and then I'm going to creating here on data frame so that you can see the score of the tan score for that. So let's say PD dot data frame. So it should be the capital frame, and inside that you can give it here the training accuracy. Let's say train accuracy is nothing but the L1, and the test accuracy is nothing but the L2. That's why taking here the list. Okay, you can give it to here. Let's say L2, and then the cross validation score. Let's say CBS cross validation score is nothing but the L3. Now you can simply go into run it. So okay, syntax error, obviously syntax error. Now hope to fine. Now you can see here the DF1. So this is the train accuracy, testing accuracy, and the cross validation score. So we can see that train accuracy is 74%, 75%, 75%, and cross validation is same as well, 0.747. So now we can simply going to taking here one random state. So we can copy here this thing. So copy here this thing, and I'm going to removing here these ones. So we just give it here the random state call 42 that we actually use in every cases when you actually give it a random state value. So just using here tan random state value, and for the tan random state value, it will giving here some different types of results. Okay. So if I using here a random state value as a 42, what happened? Let's see. And same thing, linear regressions, and we simply going to removing this thing because it's not needed at all. We can simply going to painting this out because we don't need to show this out in a way of data frame because we don't have any tan value, just having one single value. So we can simply go into printing this out. So instead of this L1 dot append, we can simply go to using the print statement because we need to painting three things. So let's say print for the testing data, and then you can simply painting here for the cross validation score as well. Okay, so we need to also using here another one. It should be the this ones. Okay, now let's see. So this is the score called 0.72 or you can using here this one. It should be the 49 or 50 maybe, so that you can got in here some good results. In the testing score, you actually getting here uh, 80%. So in here in the random study, you can see that if the testing value is good, the random method that you're going to choose here. See, in the case of 2, I mean 42, it should be 42. So we got in here the testing score is nothing but the 80%. So that's why choosing here this 42 as a random state, because it's nothing but uh, mathematically approved, but we see that on here in the code. So you can see that 80% is nothing but the testing accuracy, and 74% is nothing but the cross validation scores. Okay, so now let's try to using here the another models as well. Also, we are going to calculating here the square error value as well in case of SPR, support vector regression. So we're simply going to first import it here. Let's say from scikit-learn.metrics, we're going to import here the R2 score. So R2 score actually define that how your model actually work, or how your model perform in terms of your data. If it is close to the 1, that's when model is better fitted, and if it is close to 0, the model is not better fitted to your training data. So we can simply go and creating here an instance of the is our SBR model, I mean support vector regressors. And then you can simply go into using here SBR model dot fit. So you can copy this thing from here, same thing. So you can give it here xtrain. Okay, it should be the xtrain, and the y frame. And after that, it's simply going to predict it. So let's SBR model dot predict, and we can give it to here xtrain data, because we need to passing to inside our R2 score value. So we need to also calculate here the predicted value, I mean actual value, and the predicted value. So we're simply going to say that, let's say this is a y pred train 1, like that. You can give it here any kind of name, and let's say y pred train number testing number 1. Let's say test number 1, because you're going to using here the testing data. That says peer model dot predict, and you can give it here the x test data. And after that, we're simply going to calculating here the R2 score value. So let's run it first, and then we're simply going to uh, calculate the R2 score. Let's say R2 score, and you can simply going to give it here the y underscore train and y prediction train 1. Okay, so they're giving me here on value. You can see it's negative. That means it's not fitted at well on here in the data. So you can copy this out. We can paste in here, and second one, I mean third one, is nothing but this cross validation score. So you can copy this out, and instead of the ALR model, we're simply going to pass it to here the SBR model. And in case of here, we can simply going to printing. That's a print, and then start up the print and print. So instead of this y train, we're simply going to pass it here the x y test data, and it should be the y pred test 1. Now let's see the score. So you can see that this is nothing but the minus. I mean the data is not fitted at well. Okay, so let's try to apply here the another model. It's called random forest classifier, random for guessers. So let's try to use it here. Okay, so what I can do is simply going to initialize here the RF model. Let's RF model equal to random forest regressors, and then you're simply going to give it to the random state 42, because you're already testing this out, right? And then you're simply going to using her RF model dot fit, and then you can give it to the x train and the y train data. And same thing, we're going to copy it from here. So you're going to copy it from here. So instead of using here the SBR model, you're going to using here this RF model, and 1 should be the 2, replacing at a 2. And then we are going to copy here this thing, to calculating here the R2 score. So we simply going to give it to here the two, and this should be the RF model. Now let's checking for here this ones, the value, and you can see here cross validation score is near to 1. I mean 0.97, near to 1. That's mean random forest is try to fitting the data, is try to fitting the data correctly. Okay, so you can see try to fit in the data correctly, but in the case of SBR, it's unable to fit in the data. It will go to the minus. That's mean it will not fit in the data wells. This is how we can actually checking here that our model is fitted correctly or not. In our actually without actually uh, painting in the scatter plot. Okay, so you can see that a random forest is actually working very fine, but it's better you can also do the fine tuning on that. Okay, I mean regularization is called the regularization. So we can do the regularizations using here the grid search CB. So let's try to import it first. Let's say from scikit-learn dot model selection. Let's say model selection, and you're going to importing here the grid search CB. Let's say importing here the grid search CB. So if you don't know what is the grid search CB, you can also follow here the videos about the healthcare. I already making so many projects regarding that in the multiverse series. So you can just go that what is a grid search CB and how can you actually using the fine tuning. Okay, I just using here one single param grids in order to using the grid search CB. You can using any of them. Okay, so I'm simply going to first initialize here my random forest. Let's say random forest, and after that I'm going to using here this random state. Let's say random state is equal to 42, and after that let initialize into a variable called estimator. So now in the case of random forest regressors, it having one hyper parameter is called the number of estimator. So what I can do is simply estimate them. We simply estimate them which one is the best value or which one is the best parameters. So that's why I'm going to initialize here one param grid, and then we're simply going to give it here some kind of random value for the number of estimator. So let's say number of estimators. Okay, let's say number of estimators, and then we're simply going to give it to, let's say 10 comma let's say 40 comma 50 comma let's say 98 120 150. Okay, you can give it here any kind of value, but it's better you can follow this along with me. Okay, so then I'm going to initialize here my grid. Let's say grid equal to grid search CB, and inside that I'm going to pass here my estimator, and then param grid, this param grid, and the scoring I'm going to using here this one R2. Okay, let's say R2, and then CB is nothing but the cross validation is nothing but the 4 in the case of grid. Now you can simply go using here the same thing. So I can, let's say grid dot fit, and inside that I'm going to give it here my X train data, and I'm going to give it here the Y train data, and after that I'm going to painting here the grid dot best parameter. Let's say grid dot best parameter, which is a best parameter in the case of number estimator. Now let's see, it will give me some kind of warning because I'm actually using Python 3.8, so that's why some kind of uh, error actually coming up. Okay, so let's see, we getting so many error because it will try to cross validate it. It's not even, it's not a actually error, it's nothing but the warning in the data conversations. Yep, it's now, yep, you can see number of estimator is nothing but the 98. The number estimated that you got here 98 as the best parameters. So let's try to run it again and see. So just wait for a few seconds and let's see what kind of things that he actually got. Okay, in another ones. Okay, just avoid, and after that we're simply going to enter our tutorial zones. Just wait. Get it running because yep, 98. So the 98 is nothing but our best parameters. So what I can do is simply going to now initialize here our random forest, and then you can give it the random state random state is nothing but our 42, and that number of estimator, let's say number of estimator is nothing but estimators is nothing but the 98. And then that's our RF model. So we're simply going to fit it, so we can copy it from here. So we can copy the same thing from here, this one, but we need to removing here these things. Okay, so let's removing this thing, and then we're simply going to running this out. Okay, we can running this out. Yes, we can running this out. We can running this out. Now let's see. So you can see here 97.37 and 88. Okay, so if I see the previous one, 97.39 and 87.97, but it increases in the case of testing data. You can see 97.37, right? And this one, I hope so, it decreases, I don't know why. And in the case of 87, it converted into the 88. That's a good point. And it's 83.66. And if I see the previous one, it 83.68. I don't know why. Maybe it's getting here some wrong number of estimator. I don't know. Okay, let's try to add it here 100 as well, because we are not adding in here the hundreds. So let's try running it again. Okay, because we just added here the 98, it's maybe getting here the 100 as well. So let's see. Let's wait for a few seconds. And now let's wait for that. It's fit in the data because we just added here the cross validation score as a 5. So that's why. Because this is a data science project, right? You need to wait for that. Okay, 98. Okay, that's not a problem actually. So if I just using here, there's, let's say 120. So what I got, let's see. So you can see here it also increases, and but the testing data is not increases. Okay, testing data is not increases, but it's better. We can using here the 98. Okay, let's say 98. I don't know why this kind of error actually coming up here. Too much. Oh, anyway. Okay. So now we're simply going to using here the another one that's called a gradient boosting. So the technique is almost same. You can using the grid search CD. So it's better I can type it here, and after that I'll be back again and I'll make you understand that what actually happening on here. So I just type it here, and you can see here actually using here the gradient boosting regressors, and also give it here some kind of hyperparameter, number of estimator, the learning rate. And let's try to running this out. Same thing, okay, exact same thing. And now let's try to using here this xgb boost. Let's try to running this out, and also try to running this out as well. So you can see here actually using here this number of estimator as a 15s, or the max depth is nothing but 3. I just already pre-computed this one before, so that's why actually using this one. You can see here the same thing, you can same value. So same thing, just like the random forest, you can getting here the number of estimators and this thing. So you can see here learning rate is 0.2 and number of estimators is starting with the 20. Okay, I just get it here in the case of gradient boosting. Now in the case of XGB, you can see here I got it here gamma as nothing but a 0, and max depth is 3, and number of estimate is nothing but a 15. Okay, so you can see here actually using the same thing on here. Okay, don't worry about this code. You can get this code in the video description of the GitHub link. Okay, so now what I can do is simply going to creating here one data frame for the feature importance, so that you can see that which feature is important in terms of our machine learning model, because our machine learning model started getting some pattern from our data, right? So in data we having some important features that based on this feature our data may be, our machine learning model may be getting some kind of patterns. So let's try to using here a data frame. Let's say data frame. So let's say data frame, and inside this data frame we are going to give it the data. So let's say grid dot best parameters or best estimator, which one is the best estimator, and in the best estimator which one is the feature importance. And then you're going to give it the index. Index is nothing but our x dot column, and then our column is nothing but the importance. I mean, we're going to creating here a new column called importance because this is a data frame. So let's say importance. In case of data frame, you have to give it here one column name as well. Now let's store it inside a variable. Let's make it as a features importance. Okay, like that. Okay, let's see important. So let's running this out. Let's try to see this one feature important. Now in here you can see here age is a 0.05% important, and this column is 0.005% important, and BMI is this one, this one, this one. Now we can also filtering this out. Let's start filtering this out. So let's say feature importance, and from here we simply going to take the feature importance, and if the feature importance is the greater than 0.01, that you are taking here as my important features. So let's taking it here. Let's say importance, and if it is greater than 0.01, we're taking at an important feature. Let's say important feature. Okay, and now let's see the important feature. Which one is the important features actually? So those are the important feature. Age, BMI, the children, and the smoker are the important feature in terms of our machine learning model. So what I can do, we simply going to dropping this out. We can dropping this six column and the region column. So let's try to dropping this out. Let's say try to drop. Let's say df dot drop, and inside that you're going to have our data frame, and let's say six columns and the region column. Let's say regions, and then you can simply going to give it here the axis. Let's say axis is equal to 1 and in place is equal to true. Now you're simply going to taking some more shell. Let's say xf is nothing but the feature importance thing, and for the feature importance we're simply going to drop it here. Let's say df dot drop, and from here we're simply going to dropping here the charges. Let's say charges, and then we're simply going to give it to the axis. That's axis is equal to 1, and then you have the x. That's x is equal to df dot drop, and then we're simply going to give it here df of charges. So let's say charges, and then you have the x is equal to 1. Okay, then let's start using here the train, test, and split, and you're going to passing here the xf and the y. Okay, and then we have the test size is equal to 0.2, and the random state is nothing but my 42. Now the question is why this x, because you need to also calculate the cross validation score, that's why. Okay, so you can also calculate with this xf as well, same thing on here. So you can also removing these columns. If you want to do that, you can just use it here. Just I'm going to using here this xf in here, so that's why actually cutting this out. So you can also use here the one things, but it's better you can actually creating here two variable for that, because you need to calculate here the cross validations. Now our final model is called the XGB regressor, which is gamma is nothing but 0, and max depth is nothing but the 3, and number of estimate is nothing but 15. So you can copy this out. We can copy this out, and you can simply going to paste into here. That's our final model. That's the final model. So you can copy this out. We can paste it to here. We can paste it to here. We can paste it to here, as well as we can paste it to here. So that's our final model, XGB regressors. We actually feed to it, as well as we predict it for the training data, testing data, and also calculating here the R2 score, and for the training, testing, and the cross validation score for here. And you can see here that's our score. Okay, now you can simply going to store it inside the pickle file. Let's say pickle, and let's say pickle dot dump, and you can simply go to dump our final model, and then you can using the open, let's say model.pickle, and then we are going to give it here the WB mode, and then you can shift enter. It will store it, I hope so. model.pickle file that you can see on that. Okay, now we simply testing it over here with our new data. So what we can do, let's try to typing this out. Okay, sorry, unfortunately you are not running it yet, so you need to also running this out, but you need to also store it inside the X10 and a white frame. uh, the actually data you actually got on here is nothing but our previous one. So let's say X test. Why? Because see, it will just calculating here the previous one because you already have the same variable name. That's why. So now we need to also dropping this six column in the region column from our data set, and after that it's actually working on the on here. Okay, so I think I need to interrupt the kernel because it's already dropped. So I need to interrupt the kernel first, and after that I need to run it again because when the data set is dropped from the one of the columns, it will not work again. You need to stop the kernel because in the memory it will automatically dropping here the columns of the data frame. That's why. So let's try to uh, interrupt the kernel, and after that I'll run it again. Okay, so I ran it again and also actually added here the new codes. So that's one new data and it's already running. So just adding here age as a 19 and sex is a male and BMI let's say 27.9 and children let's say 0 and a smoker let's say yes and region is nothing but the not else. And you also added here the index number, and then we simply going to convert here our smoker to the categorical to the numerical yes and no. And also for the new data we actually removing here this six column and the region column because it's not needed at all, because in case of the xg post we actually removing here in the case of feature importance. So that's why you're also removing here this two columns, and after that our model will give me some kind of predictions. You can see that's the predictions. You can also changing here below on here. Let's say this is the female, and let's say BMI let's say 25.9. Let's say it having the three children and a smoker, let's say no. Okay, and let's start running this out and see. You can see here we got in here some less number of medical insurance because children is nothing but three, smoker is as well as no. That means charges is low at all. Okay, now what I can do is simply going to creating here one applications using the first API and the tailwind CSS or the HTML part. Okay, so let's start to creating here this out. So now it's time to creating here our web applications, and for this case I'm going to using here the first API. You can also using here the Flux or Streamlit. So this is the code for that app.py file. Here I writing here all the codes, and inside this template folder I having index.html file. Here I have the code about my UI part. So let's start running this first. Let's click on here and it will running these applications, and also you can see here model.pickle file. I mean that's our model file. Okay, so a simple thing, it's just simple code, it's not nothing actually fancy. So let's click on here and follow the link, and this is our applications. So if you click on predict, and you can see predicted charges is nothing but this one. You can change the value on here, let's say 45, let's say female, BMI let's say female थोड़ा मोटी होता है, let's say 35, sorry for that actually होते हैं ऐसे. So two क्योंकि खाते हैं बहुत ज़्यादा इसलिए jokes apart, no, and let's give it here southeast and click on predict. Okay, this is the actually output, the predicted charges. Okay, so simple thing, just you're actually creating it using the tailwind CSS. Now let's go on the code and try to see that how it actually work. So first go on this index.html part because this is the front end part that you can see. So we actually added here the CDN part for the tailwind CSS, and we adding here one heading that's called insurance charges predictor. And you can see here BG gray 100 is nothing but called background color is gray like that, because in the tailwind CSS you can using the shortcut. And we're creating here on deep, and inside this deep we added here some level for the ages, and we're taking here using this input tags, and you also using here the select tag for actually the drop down menu. Okay, same thing, just same thing on here. It's बच्चों का काम है भाई, बच्चों का काम है. Then after that, when the user click on the button, it will calling here a JavaScript functions called the predict charges. And this function is nothing but an async functions, asynchronous function, because it's waiting for a few seconds. It's taking the data from this server. App.py is called the server side actually. And we're taking here the data from the users using this DOM, so get element by ID, because we're adding here the id on here, and after that you're taking the all of the value from here, and we're simply going to pass into our one method called fetch, and inside this fetch we having one route called predict, and this route is called when we clicking on here, because in our app.py file we already initialized these ones, and we also passing the data in the from a JSONs, and then we're simply going to see it using the JavaScript DOM. That's called inner text. We actually showing here this predict charges. Okay. Now let's go on the app.py file that you can it's make you understand that why actually using this predict route. So let's go on the app.py file. So first we actually imported the first API. So from first API we import here the first API and request. First API is nothing but for creating here the applications, and request so that you can take in the request from our UI. I mean taking the input from the users, that's why. And Jinja to templates, so that we can loading the UI from this template folder by default. Okay. And we have the base model, so we can creating here a base model of that how our data look like, how many columns we have. Then you have the pickles, pickles because it's also loading the models, and then ubiquitous so that you can run it out, NumPy, Pandas, and for the first API, the middlewares dot course, we are going to import it here. This course middleware. So course middleware is actually needed so that you can enable the course, and you can accessing or passing the data from the another local host. But in here, you're not using here this React.js or anything else, so you don't need to using it here because we run it in the same local host, so we don't need to use any sort. But if you're not using here the React.js, but in the case you need to use here this course middleware. See, our application is running in the 8000 port. Let's say I'm going to passing here the one data in the another port or another website, so I need to using here this course middlewares. Okay. If you don't know what is the middleware, don't worry, I'll try to creating here and projects based on MERN stack, and while discussing about everything in brief. Okay. So we load here the model, and then we creating here the applications, we adding here the middlewares, and we actually initialize here the templates, and you're also creating here our base models. Okay. You can say the model, how can you create that? And then you simply preprocess the input, because you need to also convert them to the category to the numericals, that's why. And then we creating here our initial route, get route. So we creating here one home, and we're simply going to get in the response the index.htmls, and the request part we passing here the request. Okay. So now this is the UI. If I go on here and if I clicking this link, so you can see here the link, this is the actual links, I mean the actual pages. I mean this get request is coming from here. So how the user clicking on this predict button, so it will calling here this route called the underscore this slash predict. That's when it will go inside here this index.html and try to checking that is the method is post or not. If the method is post method, it will directly take in the data and try to convert it to the data frame, and after that it will try to process it and give you the result. So same thing, you can see it will just taking here smoker, it will map them, and after that it will try to actually dropping this out, you can see on here. Okay. And then it will giving me the prediction, it will just returning the prediction in the round format. Okay. And it will pass into inside this index.html part, right? That's it. Now let's try to go on here and try to testing this out. So our server is already running, so we can testing this out. Let's try to give it here, let's say 34, let's say male, let's say BMI, let's say 29, children, let's say 2 children, let's say smoker, yes, let's say southeast. Let's click on predict, and this is predicted charges for the medical insurance. Okay. So that's it for today now, and I hope you enjoyed this full tutorial, and make sure to subscribe to the channel so that you can get more videos when I'm putting here new videos. I mean, it will notify you, right? So thank you and bye bye. Namaste.